If you combine SSR and a headless CMS, what you'll find is that every time a client makes a request, you'll have to go to the headless CMS and fetch the data. What does that mean? Well, on the one hand, it slows things down. You add a bit of latency, and on the other hand, it could become a point of failure, because at some point you might lose the connection to Content Island. And what happens then? Your website might stop working properly. What can we do? One possible solution is to try adding a cache. Well, that's not ideal. Let's look at another option and see what you think. What if I downloaded the content I have in Content Island into my web server's memory, and then query that content there? I wouldn't have to call Content Island and wait for it to come back, so I'd get rid of the latency and that point of failure. In memory, it'd be blazing fast. And on top of that, if I change data in Content Island, the content gets downloaded again, automatically, with no redeploy, no downtime, and everything updating live. Well, that's Dynamic Snapshot. And today, we're going to see how to set it up locally, and how to take it to Azure for deployment using Docker.
Before we touch any code, let's look at the big picture. This is our starting point. With SSR, every page render requires a request to the Content Island API. Request, response, render, request, response, render. One by one, over and over again. Now look at how the diagram changes. First, in our CI/CD flow. The snapshot shows up, which is a JSON file with the project's model and content. It's generated during deployment, and the application loads it into memory on startup. From then on, there are no more API calls. The SSR website serves everything straight from memory. And that's what makes it fly, because there's no network in the middle anymore. Second, updates. When someone publishes in Content Island, a webhook fires off to notify us. That notification ends up calling an endpoint in our own application, and that endpoint is what refreshes the snapshot we have in memory. All of that without restarting or redeploying. And third, look at the arrow at the bottom, because it's important. The images and files are still served from Content Island's CDN, just like always. The snapshot includes the content schema and data, but media assets remain external. And those are the three pieces: the in-memory snapshot, the refresh on startup, and the webhook, so it updates live when there are changes. Let's put them together one by one. To see this in action, I prepared the following starting point. A project in Content Island, our headless CMS with car listings. An application built with TanStack Start that uses SSR and reads its data from the Content Island API. And a GitHub Actions workflow that builds the Docker image, pushes it to GitHub Container Registry, and deploys it to Azure App Service. If we look at it running, we have a welcome page. Let's click Load the Car List. This might take a moment. We've got quite a bit of data in there. And from there, we go into the details. This is the starting point. We make a request to the Content Island API when loading each page. We're going to change that. Here we have the starting point open locally with the project already set up. To work in snapshot mode, the first thing we do is download the current snapshot with the data from our project in Content Island. For that, we're going to use the Content Island CLI, which lets us export the snapshot to a JSON file. The command looks like this: npx content island export. We pass in the access token as a parameter, the read-only token from Content Island for our project. To do that, we go to our project, and in the General tab you can see there's a read token value here. We copy it, and we paste it in here. By default, it puts it in the project root in a file called contentislandsnapshot.json. However, we can specify a different path using the snapshot path parameter. And then we specify the path where we want to save it. We're going to leave it at the default path. We copy the command, drop it into the terminal, and run it. If we open the Explorer in Visual Studio Code, we can see that Content Island snapshot.json has been created in the project root with all the information. One important thing, if you notice, this shows up in gray. Why? Because I have it in my Gitignore so it gets ignored and doesn't get pushed to the repository. Whenever a developer needs to use it, they just have to run the command and download it. Now, let's switch the Content Island client over to snapshot mode. We navigate to the Content Island client file under Common API. And in Create Client, we specify here that we're going to be working in snapshot mode. If we start the project now, and go to the browser, here it is running. Hit refresh and boom, it loads instantly. In this Create Client, we also have some interesting parameters. For example, I can specify the path where the snapshot goes, which in this case we didn't set because it was the default value, but if we want to put it in a different path, we just change it, and that's it. Let's remove it. And to confirm that we're actually using the snapshot, we go over to the environment variables, and we're going to remove the Content Island red token. Let's open the terminal, and we're going to run npm run dev. And if we open the browser, let's refresh. Here we have a list of cars. Look how much faster it loads, and it's working off the snapshot. Let's add a little visual aid that will help us see what's happening under the hood. We're going to add a little detail at the very bottom that tells us which snapshot we have in memory and when it's from. Content Island gives us that information with getSnapshotInfo. We're going to create under Common API a file that we're going to call snapshotinfo.api.ts. It's going to have a server function from TankStackStart, the meta framework we're using to build this example. We'll also bring in the Content Island client. Then we create the server function. And we ask the Content Island API to give us the snapshot information and return the date it was exported. Let's add a little bit of defensive programming. We add a try here. Then we add a catch. With the error, and if it fails, we log a message to the console. And we set exported at to null. We add a closing parenthesis. And now we have our function here. Now let's implement a footer component to display it. We go over to Components, and here we're going to create a file called snapshotfooter.component.tsx. We paste in a helper function to format the date in a friendly way. As props, this component is going to receive the date it was exported. And here in the footer, we show the date the snapshot was imported. And if not, we say the snapshot isn't available. We're going to use this component in our application's root layout. We navigate to the root.tsx file in the src-your-roots directory. We bring in the API method we created earlier. We bring in the footer. And we add here a loader. That way, when the layout loads, it calls Get Snapshot Info API, and we get the snapshot timestamp. We're going to have a root component, and we're going to create it further down. We come down here and create it. We still need to add the import for outlet. That's the part of the layout where tank start router renders the corresponding child route. Let's run npm run dev. Let's go over to the browser, and here we have the snapshot timestamp. Let's see how we can push this to production. And the question here is, when Azure starts the container, where does it get the JSON from? The simplest answer is to bundle it inside the image. Let's open our Docker file. And right after this copy command, we copy our Content Island snapshot. Here locally it works because we have our Content Island snapshot.json file. But what happens in our continuous deployment process? Well, it runs on a clean Linux machine. And we need to run the Content Island CLI to download that snapshot. To do that, there are two steps. First, we need the Content Island red token from our project so we can store it as a secret in our GitHub project. So we go over to Content Island, copy the read token, and then go to our project. We go to Settings. We click on Secrets and Variables, and then on Actions. We go to the Repository Secrets section and add a new entry called Content Island Access Token. And it's going to have the value of our project's read-only token. We click Add Secret. Now it's created. And we go back to Visual Studio. And we open our app's deployment workflow. And now right after installing Node, here, after this step, we're going to create an action where we'll read our Content Island Access token from GitHub Action Secrets, and then we'll use npx to call the CLI command that downloads the snapshot. We add this block. And what are we doing here? First, the environment variable, Content Island Access token, and we read our Content Island project's read-only token from GitHub Secrets. And then with npx, we call the Content Island CLI to do an export and get the snapshot. And notice that for access token, we're passing in the Content Island Access token environment variable. Let's commit and push to main so the deployment action runs. Let's put snapshot here as the message, for example. We commit it. And we push it. And now, if we go to Actions, we already have this snapshot version being deployed to our Azure App Service. It's already been published to Azure. Let's browse to it. And here it is with the snapshot. And if we go to the list of cars, this is actually pretty fast. You could almost remove the loading skeleton. That snapshot we put into the Docker image is frozen at the moment it was built. And the container doesn't start only when we deploy. Azure can also recycle it, restart it, or bring it back up whenever it wants. And that startup could happen weeks later. So let's put a simple rule in place. Every time this process starts, it should download the latest available snapshot of data from Content Island. We'll request that on startup, but without blocking, and if it fails, we'll keep going with whatever came in the image. All of this is great in a production environment, but locally it's normal to start and stop the development server often, and even use hot reloading. And we don't want it downloading the snapshot every time we restart it, so we're going to control that with an environment variable. Let's go to Visual Studio Code. We open the NV file. While we're here, we're going to add Content Island Access Token again. We will need it to do a refresh later on. And we're going to add this environment variable. Content Island Refresh on start. Here it's set to false because we're developing locally. And now in Azure, we've gone into Settings, Environment Variables. And we're going to create a new environment variable. We click Add. We're going to give it the same name, Content Island Refresh on Start, and we're going to set this to true. We're going to click the eye to see the value, and here it's set to true. We click Apply. Apply again. We confirm. And there it is. We go back to the code. And we're going to tell the Content Island API how to refresh our snapshot. We go to the place where we initialize the Content Island API, in our case, Content Island Client, right here. And in Create Client, we add a new property. It's called Snapshot Loader, and here we're going to define a function that gets called whenever someone calls refresh snapshot. And in that function, we're going to load the snapshot from wherever it needs to come from. And the function is async. And here we're going to call export snapshot. And we're missing one thing. We're missing a parameter. What parameter are we missing? The access token, a config object. In this case, we pass it in here. Our access token, so it can access the project and download the snapshot. What this is going to do is replace the snapshot in memory. Now, right below where we initialize our Content Island client, we're going to check whether refresh on startup is enabled by checking the environment variable we created earlier, and then we'll do the reload in parallel without blocking startup. And this refresh snapshot will call the loader function we just defined, that is, this snapshot loader. Here we put the condition. If Content Island refresh on start is true, then on Content Island client we call refresh snapshot here. What this will do is trigger this snapshot loader here. If we want a little bit of debug information, I remove this, and since refresh snapshot returns a promise, I can capture both whether there's an error or not and indicate whether it refreshed or whether there was a problem. What would the loading order be? First we load the image JSON, that is, we read the file. At that point we can already respond. And in parallel we request the latest version from Content Island. The server just started up, I want a fresh copy. If it comes in, it's replaced in memory. If it doesn't come in, that's fine. We keep serving what we already had. With this, we've solved the problem of having the snapshot updated at startup. Let's see it working. First, I'm going to push the changes. Let's push it up. Since we're on main, this is going to trigger an action here. And the deployment starts. And once it's deployed, it will restart the application. Let's leave it as it is. We'll see what data it has. We're going to make a change in Content Island. You can see it's using the old snapshot. We're going to restart the application in Azure and we'll see that it's now using the new data. Let's go to the website. If we refresh, it's working. Let's make a change here. For example, the name of this car. Let's add test at the end. I go over to Content Island and right here I enter test. I click publish. And if I refresh the page, the changes don't show up here. Why? Because it's pulling from the original snapshot. But if I go over to Azure, I go to the service. I stop it and start it back up again. If I wait a little bit, when it starts up, it'll pull down the latest version of the snapshot, which does include that test label. Let's go back to the website. We refresh. And here you can see it. This is great, but we're not going to be starting and stopping the server every time someone publishes a change. What we want is for the website to update on the fly without restarting. We can handle this very simply with 3 pieces. By exposing an endpoint in our application that refreshes the snapshot when it's called. By implementing a GitHub action that calls that endpoint and configuring a webhook in Content Island that triggers that action whenever new content is published in our project. Let's define the endpoint that triggers the refresh. Before we start implementing, let's think a little about security. We don't want just anyone to be able to call that endpoint and refresh our snapshot. So we're going to set up a shared secret between the action and the endpoint. We'll define it as an environment variable and send it in the request header. If it doesn't match, the endpoint returns a 401 and does nothing. We go to our environment variables, to the env file. We define this environment variable. For development, I'm just using some silly text. Use a random secret that's long and secure. When we move to production, we'll generate that secure secret and we'll add it as a secret in GitHub Actions and we'll add it as an environment variable in our web app deployed on Azure. Now let's go to the endpoint itself. Since we're using TanStack start, we create a file root and tell it that it's a post endpoint. We go to src roots, and here, we're going to add a new file called api.contentisland.refresh.ts. We add the imports to bring in create and create file root from TanStack React Router and the Content Island client from our common API. We create our file root, which is going to be API Content Island Refresh. And here we say that on the server side. We're going to implement these handlers. A post method. And before importing anything, we check that the shared secret I have with the GitHub action was sent to me. So I have my secret from the environment variable. And on the other hand, I have here, which I get from the request header. A header with the value X refresh secret, and I check it. I see that it matches the secret I have in my environment variable. If not, I tell it you're not authorized. And if it does, I call Content Island refresh snapshot, so it goes to Content Island, fetches the latest snapshot, and loads it into memory. If this fails, I log a message to the console or to a logger. But the application keeps working. If you want to make it more robust, you could check whether the server is down or returning a 500, and then try refreshing again after 5 minutes. Now, one small detail. Besides the post, we're also going to handle the GET here, and we'll say that if you try to make a GET request to this route, it returns an error. This is just in case you try to access that route and that GET handler isn't set up here, because otherwise the application would return a 200 and it would look like the endpoint is broken. Before we continue, let's make sure this works locally. I'm going to stop the server. We run npm run dev. You check that it's working. Perfect. Now we go over to Content Island. I change the car model text. For example, instead of test, I put test 2. I click publish. If I go to my car list, you can see the old one is still showing. But if I call the refresh endpoint now, it's going to trigger a refresh and we'll have the new data in our car list. I'm going to run a command from the terminal to simulate that call. I'll run a curl command from Linux, make a post to localhost 3000/API/content/island/refresh, and put the header here. With this -h, I'm indicating it to create an xrefresh secret header. We read the secret from the environment variable. In this case, since we're in a local environment, there's no secure secret. It's this test text. We come over here and paste the secret. We open a new terminal and run this command. Here we can see it responded successfully. If we go to the site, to our localhost 3000 and refresh. Here we can see the new data, test 2. The next step is to create a GitHub Actions workflow that does exactly that. That manual call we made, we're going to do it in a GitHub Actions workflow. We're going to need 2 new secrets. So we go to Settings, and here under Secrets and Variables, in Actions, we go to Repository Secrets and add one called Refresh Secret. Here we do use a more secure value. You can generate this value yourself using secure token generation tools. We click Add Secret, and now we're going to create one more. And this is going to be the public URL of our endpoint. If you're following along with the example, this value may vary. In my case, it's this one. Cars example Azure websites API Content Island refresh. We click Add. I already have these secrets ready, and in Azure I'm also going to add an environment variable where I'll store the refresh secret. We click Add. Refresh secret here. And we paste it. We click Apply, and then click Apply here again, so all the changes we've made are applied. Now let's create our new GitHub Actions workflow. We come over here to GitHub Workflows. and we add a new file that we're going to call refresh.yaml. We give it a name, and now we tell it here that it can be triggered either manually from the GitHub Actions tab with Workflow Dispatch or from an external system through the GitHub API, for example, from a Content Island webhook. That's repository dispatch. Important, remember this content refresh because we'll use it later. Now we're going to define the task it has to perform. Under jobs, we create one called refresh. We tell it to run on an Ubuntu machine. And it's only going to have one step. And that's going to be making a post request to the refresh endpoint. Before running curl, we read the refresh URL and the shared secret from the secrets so we can identify ourselves as the ones allowed to make that request. And now, in run, we run curl, making the post request where we pass the URL, the refresh endpoint, and also send the shared secret in the header. If everything goes well, that is, if the refresh endpoint returns a 200, then we consider the workflow run successful, and if not, we mark the run as failed. I'm going to push the changes to main. I go to the Actions tab. I select the new action I created, Refresh Snapshot, and I can run it manually. Let's see if it works. In this case, the site currently says Test 2. I go over to Content Island, and I'm going to change this, and instead of Test 2, I'm going to put Refresh. I click Publish. If I go back to the site, I can see it's still showing the old value. But if I run this workflow again and tell it to execute Refresh Snapshot manually, if I go to the site now and refresh, it should show the new data. I come back over here, we refresh, and there you have it. Let's move on to the last step, which is having Content Island call the GitHub Actions workflow when someone publishes new content. So GitHub knows the call is coming from Content Island. We need Content Island to be able to identify itself. So we're going to create a fine-grained GitHub personal access token with contents read and write permission for this repository. We go to GitHub and click on our profile. Then we go to Settings. And under Developer Settings, we click on Personal Access Tokens, Fine-Grained Tokens. And we click Generate New Tokens. Let's call it Cars Example Demo. The owner in my case is the Content Island organization, where I have the repository. I can give it an expiration date. Here, depending on your security requirements, you can give it more days or fewer days and keep renewing it. And now comes a very important part. Which repository we're giving access to. We're going to say it's for a specific repository, and here I'm going to say it's Cars Example, this one here. Next step, what permissions that fine-grained personal access token is going to have. We go to Permissions and add for metadata, read permission, and for workflow contents, Make sure it has read and write permissions. Now let's click Generate Token. We confirm it. And here we have the token. Very important, copy it and store it somewhere safe, because once you've created it, you won't be able to view it again. You can always create another personal access token. So we copy it. And we go over to Content Island. Go to the Webhook tab and create a new webhook. It's going to be for GitHub. In Repository Owner, we enter whoever owns the repository I'm working on. In this case, the owner is Content Island. If you had a personal account, this would be the username for your personal account. So I come here and enter Content Island. The repository name in my case is Dynamic Snapshot Car Sample. I come over here and I paste it. And the GitHub token is the one I created earlier. I'm going to paste it. And I can get the event name from the refresh workflow. I go to my repo's source code, to workflows, to the refresh workflow. And on line 6, you can see I have types. Content refresh. That's the name I gave it. I copy it. I come over to this event name field, or event name, and I paste it. We click Save. We go back, and now we have here our webhook ready. And now let's test it. I go to Content. I choose this car, and here, instead of refresh, I'm going to put here Auto. I click Publish, and automatically, the content refresh has been triggered. Notice it only took 5 seconds to run, super fast. If I go to the website now and refresh it, the new value appears, Auto. And all of this without restarting, without redeploying. And the content updated in a matter of seconds. And one important thing to keep in mind, this solution is intentionally simple and designed for a single instance. The endpoint refreshes the process memory of the instance that receives the request. If tomorrow you scale to multiple replicas, some of them get updated and the others keep the previous version. To cover that more advanced scenario, there are 2 already documented patterns, and they require surprisingly few code changes. Basically, with the snapshot loader, you can either store the snapshot in an S3 bucket or an Azure Blob Storage, or you can also use Redis Pub Sub, where each replica subscribes to a channel and refreshes itself. To wrap up this step by step, let's go over the key points. With this setup, we stop calling the CMS API on every request. The content is served directly from memory, and when someone publishes a change, the webhook updates the snapshot automatically. That gives us the best of both worlds. Performance close to a static site, but without having to redeploy every time the content changes. And on top of that, if the CMS is temporarily unavailable, the website can keep running with the last loaded snapshot. I'll leave the full project and all the documentation in the description. I hope you find it useful, and I'll see you in the next video.